Hello everyone, welcome to this session, which is nothing but again a block friction problem, which is the two blocks have been connected to each other. Now we'll read out the statement of the problem before drawing the free body diagram. So statement of the problem goes like this. There are two blocks here, block A and block B, of masses 12 kg and 6 kg respectively, which indicates mass of block A is 12 kg and that of block B is 6 kg. So mass of block A is 12 kg, mass of block B is 6 kg, and respectively are connected by a light extensible cable passing over frictionless pulley. So that is nothing but frictionless pulley, which has been named as C, and which can rotate freely either in clockwise direction or anti-clockwise direction depending upon which side the weight will be more. So this particular pulley connection, which is C, is been mentioned as frictionless pulley. That is mu, that coefficient of friction at the pulley junction will be 0. And if mu is 0.12 at all contact surfaces, now wherever apart from pulley junction, wherever the blocks have been placed in contact with either with the surface or with each other, the coefficient of friction shall be considered as 0.12. So coefficient of friction is 0.12 at all other contact surfaces. So we need to find out the smallest force P for which the equilibrium is maintained. So what has happened here is the weight of block A and weight of block B, that is mass of block A and mass of block B has been given. Mass of block A is 12 kg whereas mass of block B is 6 kg. If the block were of same masses now, if block A and block B are of same masses, if block A is of 6 kg and block B is also 6 kg, that indicates neither of the block will move in the downward direction. So in that situation, the application of the force will not be required to maintain under equilibrium position. Whereas here the situation is in the reverse condition. Mass of block A is greater, mass of block A is greater than mass of block B, wherein 12 kg is the mass of block A and 6 kg is the mass of block B. So which indicates mass of block A is greater than mass of block B. So whichever direction that particular block has been placed, along that particular direction, the object will move in the downward direction. So first condition, we need to draw the free body diagram. Next is to draw self weight. Now self weight will be always in the vertically downward direction. Next is to draw normal reaction component. Normal reaction component will always make an inclination of 90 degrees to the plane of contact. Fourth condition is frictional force will be always opposite to the movement of the body. Frictional force will be always opposite to the movement of the body. Now to draw the free body diagram, block A is been connected with the wall and also has been connected to block B. Whereas block B is connected only to one surface, which is nothing but block A. At the other surface, there is no connection with respect to any contact surface. It is only the external force P. Now what will happen, what will be the function of this particular force P is, as mass of block A is greater than mass of block B, so obviously block A will move in the downward direction. So as a resultant, block B will move in the upward direction. Now the contention of placing this particular force P is to apply a force on B. As a resultant, B will transfer further force to A and all the whole system will be kept under equilibrium position. It will be kept under a compression state from P is been applying a compressive force on B. B will further apply a compressive force on A. So this is the reason why P has been applied, so that A does not move in the downward direction. If you happen to apply a force P towards the right hand side, what will happen is B will lose the contact with A. As a resultant, A will freely move in the downward direction. Not to happen so, you are going to apply a pushing force on block B, which will further apply a compressive force on block A. As a resultant, it will be sandwiched in between wall and block B, and block A will be kept under equilibrium position. That is the reason why force P has been applied on block B. So A is subjected to two surfaces. Two surfaces, one is wall surface, other one is block B surface. Whereas block B is subjected to only one contact surface, which is nothing but contact surface with block A. So you are going to draw the free body diagram after isolation. Now isolation of this particular block A. So block A is been drawn after the separation in this fashion, and block B adjoining will be drawn in this particular condition. Now, as block A weight mass is greater than block B, so 12 kg will be shown in the downward direction. 12 kg converting in terms of Newton, 12 into 9.81. So as this moves in the downward direction, result tension force will be applied in the upward direction. As this is applied here, this force shall also be applied in the upward direction. Reason, if you happen to cut this particular string, 12 will move independently downward, 6 will also move independently downward. So 6 kg will also be shown in the downward direction, converting in terms of Newton, so 6 into 9.81. So this is nothing but after conversion from kg to Newton, because definition of Newton is, it is a force required to displace a body of mass 1 kg with an acceleration of 1 meter per second square. For that reason, you are going to multiply with 9.81, which is an acceleration of 1 meter per second square. Now coming on to this is free body diagram with respect to the sulfate. That is, sulfate is shown in the downward direction. Now coming on to the normal reaction. As the wall surface here is vertical, reaction will be applied towards the right hand side. Imagine if this particular wall is not been present. P will push the block B towards the left hand side. B will further push the block A towards the left hand side. Now to allow a displacement towards the right hand side, reaction offered by the wall will be towards the right side. So this is nothing but the reaction force component offered by the wall, which I shall call it as N1. Further, this N1, the P will be offered here, and there is a contact surface between block A and block B. So which will offer a reaction component called as N2, and N2 will be further transferred here towards the inward direction. So P will offer a reaction component on block B towards the left hand side. Reaction will be towards the right hand side. Equal and opposite force will be towards the left hand side, and N1 will be pushed towards the right hand side. So these are the reaction component, wherein reaction component will be always perpendicular to the plane of contact. Here perpendicular plane of contact is vertical, reaction will be perpendicular, which will make 90 degrees. Here plane of contact is vertical wall, reaction will be again perpendicular to the plane of contact. So which is nothing but the third condition, reaction will be always perpendicular to the plane of contact. Now coming on to the direction of the frictional force. Now frictional force direction is dependent upon what direction the body will try to move now. Now here there are two bodies, two blocks which have been placed in contact with each other. Now coming on to this particular direction, as the mass of 12 kg mass is greater than B mass, so A will move in the downward direction. If A moves in the downward direction, frictional force will be opposite to the moment of the body, so frictional force will arise in the upward direction like this. Because as 12 kg mass is greater than 6 kg, first condition, A will move downward. If A moves downward, A has a contact surface at two junctions, one at the wall position, other at the block B position. This is the contact surface for frictional force at the wall position. This frictional force I shall call it as F of F1, which will be called as mu times of N1. Likewise, this is the frictional force between block A and block B. This is the frictional force between block A and block B, which shall be named as F of F2. And this F of F2 will be mu times of N2. Now as this is upward, so frictional force here shall be shown in the downward direction, because both the forces should be equal in magnitude and opposite in direction. So this frictional force will be F of F2 again, which will be mu times of N2. So this will be the direction of the frictional force between block A and the block B. Here it will be shown in the upward direction because block A will move downward direction of impending motion is downward. So frictional force will be opposite to the movement of the body. Both will be shown in the upward direction. As shown here it is upward, on block B it will be shown in the downward direction, which will be mu times of N2, which will be written as mu value has been given as 0.12. So F of F2 shall be written as 0.12 times of N2. Likewise, F of F1 shall be written as 0.12 times of N1, because coefficient of friction of all surfaces is 0.12. There is no variation with respect to the coefficient of friction, so mu value will remain same. Now what varies? Friction force magnitude will vary depending upon the magnitude of N1 and N2. So this will be the free body diagram pertaining to block A and block B. So we have also considered the fourth condition, which is frictional force is opposite to the moment of the body. Now to begin with the solution, we need to start with one particular block. So we shall start with block B now. So if the solution proceeds like this, first I need to apply summation Fy is equal to 0. That means you are going to add up all the forces parallel to y direction. What it intends is, when you add up all the forces parallel to y direction and equate it to 0, you are not permitting this particular block to move along the vertical direction, that is along the y direction. Which indicates if you don't have any force acting along y direction, obviously object will not move along the vertical direction, that is along the y direction. If you sum up all the forces along y direction, T is upward, so positive. Any force acting upward is positive. Any force acting downward is negative. Any force acting towards the right hand side is positive. Any force towards the left hand side is negative. So these are the sign conventions that we need to follow. So as T is upward here, so it is positive. 6 into 9.81 is downward, so minus 6 into 9.81. Then apart from that, you also have a frictional force which is downward here, minus of F of F2, that is equal to 0. So reframing this equation, T is equal to 6 into 9.81 plus of F of F2. So which will be 6 into 9.81. F of F2 value is 0.12 times of N2. So this is the value of T now. So keep this equation as it is. Now we shall write down the equation for summation Fx is equal to 0. If we write down summation Fx is equal to 0 for block B, P is towards the left hand side. Left hand side direction force is negative. So minus of P. Then N2 is towards the right hand side, plus of N2. That is equal to 0. So N2 shall come out to P. So this will be the equation for N2 now. So this N2 can also be substituted here. This equation you call it as 1. This equation you call it as 2. Substitute N2 is equal to P in equation 1. If I substitute N2 is equal to P in equation 1, T will be equals to 6 into 9.81 plus 0.12 times of P. So as a resultant, T will come out to 6 into 9.81. We shall come out to 58.86 plus of 0.12 times of P. T is equal to. So name this as equation number 3. So this you keep it as it is. Further this will be required to find out the value of P now. Next we consider block A. So we shall redraw the particular free body diagram of block A. So block A free body diagram was drawn in this particular fashion, wherein T was subjected in the upward direction, N was towards the right hand side, N2 was towards the left hand side. Frictional force here was shown upward, F of F2, which was 0.12 times of N2, which is mu times of N2. Actual value of F of F2 is mu times of N2. Likewise, frictional force here shall be F of F1 is equal to mu times of N1, which is 0.12 times of N1. 0.12 is coefficient of friction which has been given. Then self weight of this particular block A is 12 kg. So converting in terms of Newton, 12 into 9.81. So these will be forces that have been applied for block A. Two forces as a frictional force, one force as a reaction component offered by the wall. This is reaction component offered by the wall. This is reaction component offered by block B, and frictional force offered by block B, frictional force offered by block A, that is by the wall. And T is the tension force that will be connected by the string, and self weight is downward. So these are all the forces related to block A. Now again, as the same procedure applied to block B, we are going to apply the equations of equilibrium even for block A. Considering summation Fy is equal to 0. When you consider summation Fy is equal to 0, minus 12 into 9.81. Again, all upward force positive, all downward force negative, all right hand side forces positive, all left hand side forces to be negative. So 12 into 9.81 plus of T, then plus of F of F1, this is upward, plus of F of F2, that is equal to 0. Only 12 is downward, so negative. Remaining all forces are upward, so considered as positive. So T plus F of F1 value is mu times of N1 f of f2 value is mu times of n2 is equal to 12 into 9.81. So as a resultant, t plus of 0.12 times of n1 plus 0.12 times of n2, 12 into 9.81, 12 into 9.81, which will come out to 117.72, 117.72. So we need to find out the value of n1, n2 or the value of p first now. Now t value is been substituted now. Now what is the value of t now? T value is 58.86.12. T 58.86 plus of 0.12 times of p. That is equation number 3. 58.86 plus 0.12 times of p. So this is a term from equation 3. This term is term from t from equation 3 plus of 0.12 times of n1 plus of n2 value is already been written in terms of p. So which can be written as 0.12 times of p. That is equal to 117.72. So we need to find out again the value of n1 in terms of p now. To find out the value n1 in terms of p, take summation fx is equal to 0. If I take summation fx is equal to 0, you are going to add up all the forces parallel to x direction. Here, f of f1 is along y direction, f of f2 is along y direction, t is along y direction, 12 kg is also along y direction. So forces acting along x direction are n1 and n2. n1 is on right hand side, so positive, plus of n1. n2 is on left hand side, minus of n2, that is equal to 0. So n1 will be equals to n2. So what is the value of n2 now? n2 value is already been calculated as p. So substitute as n1 is equal to p, because n2 value is already in terms of p from equation 2. So n1 will be equals to p. Substitute this n1 equation, that is nothing but equation, this is equation 4, this you can call it as equation 5. Substitute equation 5 in 4. When I substitute equation 5 in 4 and rewrite, which will be written as 58.86 plus of 0.12 times of p plus of 0.12 times of p, n1 is again p, plus of 0.12 times of p is equal to 117.72. That is 12 into 9.82, 9.81 will come out to 117.72. So we shall solve this particular part. 0.12 plus 0.12 plus 0.12, which will come out to 0.36. 0.12 plus 0.12 plus 0.12, which will come out to 0.36 times of p. 0.36 times of p is equal to 117.72 minus of 58.86. So p value will come out to 117.76 minus of 58.86, which will come out to 58.9 divided by coefficient of p is 0.36 divided by 0.36. So p value will come out as 0.36. P value shall come out as 163.6 Newton. So this is how we are supposed to find out the value of p. If p value is 163.6, n1 value is also 163.6. If p value is 163.6, n1 is also 163.6, which itself is equals to n2 value. So this is how we are supposed to find out. So n1 will be equals to n2 is equal to 163.6. So frictional force F of F1 will be 0.12 times of 163.6, which will come as 19.632. And F of F2 will also be 19.632. Then what shall be the value of T now? T value is here now, which is T is equal to 58.86 plus of 0.12 times of P. So we shall come out to 58.6. So 0.12 58.86 plus 0.12 plus 0.12 times of p value is 163.6. So wherein t value will get out as 78.492 Newton. So these are nothing but the values related to block A and block B. So this is the minimum magnitude of the force required so that block A does not move downward. Minimum magnitude required is 163.6 Newton. Any magnitude less than 163.6 Newton will lead block A to move in downward direction. As a resultant, block B will move in the upward direction. Considering the same cases, the frictional force and the normal reactions have been considered. So this is how we are supposed to solve problem related to block friction. Thank you. Have a nice day.